Previously, we learned how to solve linear equations involving fractions. This is example we talked about in section 2.2. And today we're going to look at how to solve fractional equations in section 4.5. Comparing these two problems, we can see they're very similar. So first of all, they're both equations. Well, the first one we can call it a linear equation, but the second one we can't because the denominator contains variables. They both have fractions. Technically, this one here should be called a rational expression instead of a fraction because the variable is in the denominator. But the problems we solved in 2.2, we only have numbers as the denominators. The process to solve these two problems are almost the same. So recall that what we did in section 2.2, when we have an equation involving fractions, we can choose to get rid of all the fractions. So this is what we're going to do here. First of all, in order to get rid of all the fractions, we need to find the least common denominator, which is also the least common multiple of all the denominators. And in this case, we have 5 and 3. That's going to be 15. So if you don't remember how to find the least common denominator, go back to watch the video under week 1. So now we're going to multiply both sides of the equation by 15. So multiply the left-hand side by 15. Also, we multiply the right-hand side by 15. Now, on the left-hand side, notice that we have 1, 2, 3 terms. We need to distribute 15 to each of them. So that gives us 15 times 3x plus 1 divided by 5 plus 15 times x minus 15 times 4, which gives us 60. On the right-hand side, we have x minus 2 over 3 times 15. We're going to go ahead and put 15 in the form of a fraction, 15 over 1. So now we can first reduce the numbers. 5 goes into 15 3 times, and we can reduce that. And then we're going to distribute 3. We're going to multiply top and top. Notice the second top has 2 terms, so that first top 3 has to multiply with both terms in the second top. So we have 3 times, we distribute 3 to 3x, that's 9x, and 3 times positive 1, that is positive 3. And notice the bottom 5 is reduced to 1, and we can multiply 1 and 1 to get over 1, but because 9x, anything divided by x will be the sum. So we can go ahead and get rid of 1, the denominator 1, and continue to copy 15x minus 20. And similarly, we can reduce these numbers. 3 is reduced to 1. We divide both of them by 3. So we get 5 up here. And again, top times top, this 5 needs to multiply with both of them. So that gives us a 5x minus 10. So notice that this process, finding the least common denominator of the least common denominator, and also multiply both sides by the least common denominator, will get rid of all the denominators. And for the rest of the part, we just combine like terms and get x by itself. All right, so we are going to, the first 2 steps are going to be the same. We have rational expressions, or you can say fractions, and with the variables in the denominator, we still found the LCD first, try to get rid of them, get rid of all the fractions. So we can look at the denominator. We have an n, we have another n, that's it, because the denominator of 10 is pretty much like 1. So we're going to find the denominator. We can use the tip we learned before and to pick the one with the higher exponent. In this case, it's just going to be n because they're the same. And notice n goes into n, n goes into n. The other way to do it is to break down each of the denominator, and which we cannot break down at all. So we leave it and we line up with them, of course. So we bring down 1 from each column. We only have 1 column, so that will give us a least common multiple of the denominators, which is n. So after we decided that the least common denominator is n, we're going to take the same approach, multiply both sides by the least common denominator. So the left-hand side multiply by 10, and the right-hand side we multiply by 10. On the left-hand side, let me copy it down one more time. And we go ahead and put n in the fractional form, n over 1. On the right-hand side, because we have two terms, so let's distribute n to both terms. So we get n times 10 plus n times 5 over n. And now we are going to reduce the terms, the variables, or simplify. So this is a section we just talked about last week, how to multiply rational expressions. So first of all, we found the common factors we can simplify. So n is a factor, 35 minus n is a factor, and notice the bottom n is a factor. We can cancel the common factor n. We are left with 35 minus n divided by 1, but anything divided by 1 will be the self. Now, n times 10 will just be 10n. We usually like to put a number in front of variables. And similarly, we put n over 1 here, and we can reduce because n is a factor because of the multiplication sign here, and we end up with the 5. And so you can see, after we multiply both sides by the least common denominator, we end up with something similar without any fractions anymore. So we can do what we did before, how to solve linear equations involving only integers. So we end up with 35 equals 11n plus 5, and subtract 5 from both sides. Gives us 30 equals 11n, and we divide both sides by 11. And it gives us n equals 30 over 11. And for fractional equations, we must check our answer. A quick way to check it is to plug the number back into the denominator, see if it's gonna make the denominator equal 0. If it doesn't if it is equal to 0, we have to eliminate that solution. And again, you can also use your calculator to verify this is the correct solution. Now let's look at another example. So again, this is a fractional equation. The denominators contain variables. We can solve it the same way as we did it before, but this one also has a different solution. So let's do two solutions here. In solution 1, I'm still going to do exactly the same way we did it before to find the LCD. So in this case, the LCD, similar to the process of adding fractions, when we have denominators, we need to find the LCD. Notice 5x minus 2 is not factorable. No GCF, not trinomial, no difference to squares, and again, x cannot be factored down any further. So the factor of 5x minus 2 will just be the self. And similarly, 2x minus 1, the factor of 2x minus 1 will also be itself. And because they're different, I create a new column for that. And then we bring down 1 from each column and then multiply them. That will give us the least common multiple, which is the least common denominator here. So you can see the least common denominator is just the product of these two denominators. Okay, after we found the least common denominator, we're going to multiply both sides by the least common denominator. So I'm going to take 5x minus 2 times 2x minus 1. So this time the least common denominator is sort of long, and times the left-hand side. And you can also put it in the fractional form and put a 1 underneath. And similarly, we're going to multiply the right-hand side also by the same denominator, least common denominator, and put a 1 underneath. Now we can simplify these two, multiply these two rational expressions. So top times top, so pretty much this becomes a straight line. And you can look for the common denominators from the top. 5x minus 2 is the denominator because of the multiplications here. And the bottom, again, it's a multiplication. 1 times 5x minus 2. 5x minus 2 is a factor of the bottom. We can cross out the common factor from the top and bottom. And now we're left with the 4 times 2x minus 1. On the right-hand side, as 2x minus 1 and 2x minus 1 is the common factor from the top and the bottom. We can cross them out, and we're left with the 7 times 5x minus 2. So now we don't have any fractions anymore. We can get rid of parentheses by distributing the number in front of each parenthesis. And we can combine like terms. Let's move 8x to the right-hand side. So that gives us a negative 4 equals 17x minus 14. Now let's move negative 14 to the left-hand side. Sorry, that should be 27 here. And that gives us 10 equals 27x. To get rid of 27, we divide both sides by 27. So we end up with 10 over 27 equals x. Okay, so that's exactly the same idea as we did previously in section 2.2, how to solve an equation involving fractions. Find the LCD, multiply both sides by the LCD to get rid of the fractions, the denominators. Now, for this case, for this particular example, we have a different way to do it because this equation also happens to be a proportion. Proportion is a concept that, say, in two ratios are equal to each other. So we have a ratio 1 equals a ratio 2. For example, a quick example is maybe in one university, one class, there's 20 female students versus 30 male students. In another class, it has 40 female students versus 60 female students. As you can see, after we simplify them, we should both get 2 over 3 and 2 over 3. So it's technically 2 over 3 equals 2 over 3. So these two ratios are equal to each other. And when they are equal to each other, it's called a proportion. And a proportion has a very important property. The cross products are equal. As you can see in this particular example, when I cross multiply them, we get cross products are equal. So we can see 20 times 60, which is 1200, equals 30 times 40, that is also 1200. So that's a very important property of a proportion. So if we get a fractional equation which happens to be a proportion, you can use the property to do it. But in the previous example, and this apparently is not a proportion because the right-hand side is a ratio. It's a fraction, something over something. A ratio is pretty much like a fraction. But the right-hand side, it's not something over something. We have a something plus a fraction. So that does not meet the requirement of proportion. So in this case, again, what does a proportion look like? It's something over something equals something over something. Has to be a single fraction on the left. So ratio looks like a fraction, a single fraction on the right-hand side. In this case, it is a proportion. If it's a proportion, then we can solve it by quick way using the property of cross products. So we can cross multiply them to get left top times the right bottom. 4 times 2x minus 1 equals the left bottom times the right top, 7 times 5x minus 2. As you can see, this is exactly the same as what we got previously when we did the other way, multiplying both sides by the LCD, but much quicker. So without finding the LCD and multiplying both sides by LCD and crossing out the common factors. And you can continue to find out exactly the process, same process. So whenever the fractional equation is a proportion, we can take this quick approach to get rid of the denominators immediately. So we can continue to multiply both sides and just copy the process there. We should be able to get x equals 10 over 27. Okay, but remember, this only works when you have a proportion.